Hello, this video is for IXL Activity A1.D.6. It is titled Percent of Change, where you have to find the original amount, and they are indeed word problems. The 3-character code for this activity is 7 Uniform Whiskey. So our first question says, several years ago, Kayla invested in some gold. Gold is currently valued at $1,998 per ounce, which is 80% more than Kayla originally paid for it. What was the purchase price of the gold? So we do have a percent of change, and as you see in the title, percent of change. We've talked about this in other activities, like D5, the equation for a percent of change. If it is an increase, we're going to have a fraction, and we have an original amount, and that's always going to be the denominator. If it's an increase, let's see, increase, C-R-E-A-S-E, C-R-E-A-S-E. If it's an increase, then we would have to take the new amount would be greater than the original amount. We want the numerator to be positive. So we're going to have the new amount minus the original amount. And whenever we do this, this is going to create for us fraction. And we're going to do some dividing, and we would end up with a percent of change, or a percent of increase. So let me go ahead and grab this here. We'll group all that together, and we'll move that over here to the side. So if we have an increase, it's the new amount minus the original amount divided by the original amount equals the percent of increase. Now, if it's decrease, it's also going to be a fraction. And if a number decreases, then the new amount's going to be less than the original amount. So to get a positive value, we would have to take the original amount and subtract from it the new amount. And again, this is for a decrease, right? D-E-C-R-E-A-S-E. And again, we're going to divide by the original amount. The original amount is always the denominator. And whenever we work this fraction out, it would produce a percentage for us, to be exact, 8% of decrease. So I don't want all that. I just want this part right there. So let's go ahead and group all that together. And then I'll move this over here. So here's our two equations, one for increase, one for decrease. Let's go ahead and apply that to this situation that we have here with Kayla and her gold investment. So gold is currently valued at this amount. It's 80% more than what she originally paid for it. So what she originally paid for it, this is the original amount. And we're going to call that X because it's the unknown amount. So this must be the new amount here, what it's selling for now. And we do have a percentage over here of 80%. So we have two pieces of the puzzle. We have the new amount and the percentage. We need to find the missing piece, which is the original amount, which is what the title of this activity is, to find the original amount of these word problems. So it is an increase. Notice that it's more. So let's go ahead and plug all of our information into the equation here. So since it's an increase, we're going to use this first one here. The new amount we do know, it's 1,998. We're going to subtract the original amount, which we'll call X. And then we're going to divide by the original amount. Well, the original amount we don't know, so that's going to be X also. And that would produce for us a percentage. In this case, it's 80%. But we want to represent that 80% as a decimal. So we're going to go ahead and write it as 0.8. So through algebra, we'll go ahead and solve for X. Now we do have a fraction here on the left. Best way to get rid of a fraction, multiply by the denominator. So we're going to multiply both sides by X. And I'm going to write X as X over 1. And we'll multiply 0.8 by X as well. Just put an X next to it. That means 0.8 times X. The X's are going to cancel each other over here on the left, leaving us with just the numerator of 1,998 minus X equals 0.8X. Now the next thing we need to do is go ahead, and we have X's on both sides. So I want to get rid of this negative X, so I'm going to add an X to it. I'm technically adding 1 times X, or 1X. So if I add 1X over here to the other side, I would get 1.8X. I'm just adding X to each side. Actually, let's do this a little bit cleaner. Let's just do this. We're going to add 1.0x. So we're going to end up with 1 998 equals 1.8x. All right. Now we're not quite done yet. I'm going to go ahead and grab this and move this over here. Let's group all that. And let's move this up here so we got a little bit more room to work. So we still need to finish this equation. The 1.8 is tied to the x through multiplication, so we need to go ahead and divide by that same value, 1.8. What we do to one side, we're going to do to the other side as well. Now, in this situation, we're going to go ahead and let the 1.8s cancel each other, leaving us with just x. And then I'm going to use my calculator for this one. I don't want to do mental math of 1,998 divided by 1.8. So 1,998, we're going to divide that by 1.8, and that's going to give us 100 or 1,1110. There we go. So $1,110. Now, does it seem to have increased? The original amount is here. Remember, this is the original amount. It increases by 80%, so it becomes almost 2,000. So it's just over 1,000. It's now nearly 2,000. 80% is almost up to 100%. So we would think that it would nearly double. It's not quite double, but our answer does seem to make sense. Now we could plug that back in. Let's go ahead and plug that back in. I'm going to do that work over here to the side. If I want to increase, and this is from a previous activity that we had, A1.D.6 where we learned to take an original amount, increase it or decrease it by a percentage to find the new amount. And that's pretty much what I'm going to do here to double check my answer. So I'm going to take 1,110 and I'm going to multiply it times 180%. As a decimal would be 1.8. Now, if you're unsure of this, go back and watch the video for A1.D.6 where I explain this in greater detail. So if I take 1,110 and I multiply it by 1.8, indeed I get 1,998. So it checks out. My answer is indeed correct. Now there's an easier way to do this. You're probably saying, well, Mr. T, if there's an easier way to do it, why didn't you show me that in the first place? Well, that's because I wanted to go ahead and use the formula here and work that out. That way, using the formula so you saw what it was based off of and how it works. So if you wanted to use the percent formula, that would be the way to go here. Now the other way to do it, and I'm going to erase all this here so I got some room to work. The other way to do it would be realize that you have, remember the idea here, here's the original amount. This is what we didn't know, right? 1,110, this is what we did not know. We do know the percent, we know the new amount. So we know that if we take our original amount, multiply it times 80%, we're going to have to add 100% to that. Because if we increased it by 80% and multiplied that original amount times 80%, we'd actually end up with a number that was less than. Again, if you're uncertain about this, go back and watch the video for A1.D.6, and that will kind of explain what I'm doing right here at this point. So the original amount times the amount of increase, which we know is 80%, which actually is 180%. We increase it by 180% as a decimal is 1.8. That's going to equal, in this case, our new amount, which is 1,998. Now, the 1.8 is tied to the x through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of, and what we do to one side, we have to do to the other. So, the 1.8s will cancel each other, leaving us with x, and 1,998 divided by 1.8 will give us, indeed, 1,110. A lot easier this way than the other way. So whenever all these problems here are going to be finding the original amount. So we're going to take, anytime that we have an increase, we're going to add 100% to whatever the percentage is here, write it as a decimal, then we're going to have that unknown amount, x, times that increase equals the new amount, which we do know. And then through algebra, solve for x, which is indeed our original value. Next question. This year, a beauty magazine had 3,040 subscribers. That's 50% fewer than they had last year, before its parent company made some changes. How many subscribers did the magazine have last year? Okay, so I'm going to use the percent formula, go the long way around, then I'll show you the short way around. For those of you who want to know the short way now, I guess you just fast forward the video, right? So our percent equation, we know that our original amount is always the denominator. Whenever we divide all this, we're going to end up with a percentage. Up here, we have a decrease, right? So anytime that we have a decrease from an original amount, that means that the new amount is going to be less than the original amount. So if we want a positive number, we have to do an original amount minus the new amount. So let's go ahead and plug in everything that we know. This here is the new amount here. This year, Beauty Magazine had 3,040 subscribers, 50% fewer than they had last year. How many subscribers did they have last year? So this is the original amount. The unknown we'll call X. This is the new amount here. And this is the amount, the percent of decrease. So we do have a decrease situation, C-R-E-A-S-E. All right. So let's go ahead and plug in our values. Original amount is what we don't know. We'll call that X, minus the new amount, 3040. Divide that by the original amount, which we don't know. We'll call X. This is going to equal percentage of 50%. Well, as a decimal, that's 0.5, right? So 0.5. So let's multiply both sides by X, right? We have a denominator on the left side, or a fraction on the left side. So let's multiply by the denominator. What we do to one side, we're going to do to the other. This here means 0.5 times X. I'm just going to put the X there next to it. We're good to go. The X's cancel each other, leaving us with just the numerator. The numerator is X minus 3040. And we still have 0.5X. Now let's go ahead and subtract an X from each side. So I have X's on both sides. So I want to go ahead and get my X's on one side. So let's subtract 1X here. So in this case, I'm subtracting 1X. So I'm actually minus 1. Right, minus 1X. And whenever I do that, let's go ahead. I'm going to grab all this here. We'll group it. We'll move it up over here so I got some more room. So whenever we do that, these X's will cancel. Positive X, negative X. They eliminate each other. We end up with a negative 3040 equals, and then 0.5, 1/2 minus 1 is going to be a negative 0.5 X. So a little bit, if you're unclear of this, go back to lessons about solving linear equations where you have an X on both sides, okay? And now the X is tied to the negative 0.5 through multiplication. The opposite operation is division. We want to divide by the very number we wish to get rid of, which is negative 0.5. What we do to one side, we do to the other, so 0.5. Now this is going to be negative divided by negative, so it's going to be positive, and that's going to work out really well for us. The negative 0.5's cancel each other, leaving us with X. And then we end up with negative 3040 divided by negative 0.5 equals 6,080. 6,080. So it is 6,080 subscribers. Now you probably could have figured this out without actually doing that. If you realize that they decreased by 50%, you'd be like, oh, I just need to double 3,040. And you could have done that. So you kind of could have figured this one out without really doing all the math here. But I wanted to walk you through the process. And like I promised, there is an easier way to do this. So let's go ahead and look at that way. I'm going to go ahead and erase all this here. And then now let's go ahead and look at what we want to do here. So again, I'm going to have an original amount. I'm going to multiply it times some percentage, and it's going to give me the new amount, right? And that new amount is 3,040. So the original amount, the unknown, times some percentage that we're going to write as a decimal is going to equal the new amount, which in this case is 3,040. So they're losing 50%. So they get to keep how much? Well, 100 minus 50 you have 100%, you're losing 50%. That means you get to keep 50%. So 50% as a decimal is 0.5. So let's put 0.5 in here. Now we have a one-step equation. See why this is so much easier? There's just one step to do here, and that is to go ahead and divide both sides by 0.5. Because the 0.5 is tied to the x through multiplication, the opposite operation is division. We want to divide by the very number we wish to get rid of, and what we do to one side, we're going to do to the other. 0.5 is going to cancel each other, leaving us with just x, and then 3040 divided by 0.5 gives us, again, 6,080. So for the remainder of these, like the first one here, if it's an increase, I'm going to add 100% to the percentage of increase, set it up as the original amount times that amount of increase equals the new amount, and then through algebra, I'll solve to see what the original amount is. And if it is a situation of decrease, I'm going to take the original amount, multiply it times the percent that they get to keep, which is the difference of 100% minus whatever the decrease is, and then through algebra, I'll solve for the unknown value, which is our original amount. So let's go ahead and look at the next question. In 2010, Raymond paid $15,576 in federal income tax, which is 65% more than he paid in 2009. How much did he pay in 2009? So it's more than he paid, so it is an increase situation. Increase, C-R-E-A-S-E. Math teachers don't know how to spell. We have to do that out loud so it works for us. So we have an original amount. We're going to multiply it times a certain amount of increase, and that's going to give us the new amount, which in this case is $15,576. It increases by 65%. Remember, that's 100 plus 65 to end up with 165%. Is a decimal, with the decimal over two places, we'd end up 1.65. So 1.65. We have it set up. Now we just have to solve the one-step equation. The x is tied to the 1.65 through multiplication. The opposite operation is division. We're going to divide by the number we wish to get rid of, which is 1.65, because we want to isolate the variable x, correct? What we do to one side, we're going to do to the other, 1.65. The 1.65s will cancel each other, leaving us with x, and 15,576 divided by 1.65 equals 9,440. So our answer is $9,440. Does our answer make sense? 9,440, it increases to 15,000. A bit of a jump, right? 65% is a bit of a jump. So indeed, our answer makes sense. If I would have ended up with a number that was like greater than that, I would have realized, oh, I messed up. I must have done a decrease instead of an increase. Always make sure your answers make sense. So far this semester, Leslie is averaging a score of 76 points on math test, which is 5% lower than her average last semester. What was the average of her scores last semester? So let's see. She's getting 76% now. This is the new amount. And we want to know the old amount. So what was the average of her scores last? This is the old amount here. And 5% less. The new amount is 5% lower than her average last semester. So she's actually getting lower grades. So this is a decrease situation, right? D-E-C-R-E-A-S-E. So since it is a decrease situation, she's losing 5%. So how much is she getting to keep? Well, 100 minus 5 equals 95. So she's actually getting to keep 95% of her original score. Her original score is what we don't know. The original amount is the unknown. This is going to be our value of x. So 95% is a decimal, 0.95. Move the decimal over two places. Drop the percent sign. So the original amount times the amount she gets to keep, which is 0.95, is going to equal the new amount, which we know is 76. So one-step equation, right? Let's divide by that 0.95. Oh, that's not the 5, 95. What we do to one side, we're going to do to the other. The 0.95 is going to cancel, leaving us with x. And 76 divided by 0.95 gives us a answer of 80. So she was averaging 80 points. She's now averaging 76. And that's just a little bit lower, right? 5% is just a little bit of a decrease. So again, the answer definitely makes sense. Here we have some problems that we're not even going to have to really do any math to calculate. Let's go ahead and read them. John enjoys taking part in races and keeps track of all his finish times. At his most recent race, he finished 230 minutes. He finished in 230 minutes. That's 0% slower than his previous race last month. What was John's finishing time at the race last month? Well, 0% slower. It didn't change. It's still 230. There's no change at all, so it's still the same amount. Next question. The average class size at Washington Middle School is 24 students, which is 0% larger than it was a decade ago. What is the average class size then? Well, it hasn't changed any. It's still 24 students. There's no increase, no decrease. It's 0% larger, so it's going to stay the same. Next question. The PTA at Springfield High School hosts a dinner and auction every year to raise money for music and art programs. This year's event raised this much money, $99,116.84. This is our new amount. It is 52.3% more than last year. So this is an increase, right? INCREASE. See what I mean? We can't spell. CREASE. So it is an increase, 52.3% more than last year. How much money was raised last year? So this is the original amount. We'll call that X. So whenever we do an increase, we know we have to add 100% to that. So we're going to add 100% to 52.3%. And that would equal 152.3%. Now, we're going to want this as a decimal. So let's move that decimal over 1 and 2 places. We're going to get 1.523. It's a decimal. So let's go ahead and take our original amount times the increase, which is 1.523. And that's going to equal our new amount, which we know is $99,116.84. So now we just have to solve for X, right? The X is tied to the 1.523 by multiplication, so we want to divide. We want to divide by the very number we wish to get rid of, which is 1.523. What we do to one side, we're going to go ahead and do to the other. So let's divide the right side by 1.523 as well. The 1.523 is going to cancel each other, leaving us with just X on the left. And then 99,116.84 divided by 1.523 is going to give me a value of 65,080. So 65,080. Remember, it was an increase. So the original amount the year before was just right at about $65,000. Now they're almost up to $100,000. 52%, pretty good size increase. My answer seems to make sense. Mabel is trying to drink more water, so she's been keeping a log of how much water she drinks. Oh, must be waterlogged. Bad joke, right? Yesterday, Mabel drank 55.8 ounces of water. That's 100% more than she drank 2 days ago. How much water did she drink 2 days ago? So this is the original amount, and we're going to call that X. The new amount is here, the 55.8. It is an increase, so we're going to have to add 100%, then add the increase, which is another 100%. So that's going to be 200%. If we write that as a decimal, move the decimal over 2 places, and we end up with 2.0 if you want to make it a decimal. So let's take the original amount, multiply it times the increase of 100% plus the other 100%. And as a decimal, it's going to be times 2. I guess you put the 0.0 there if you want. And that equals the new amount, 55.8. So now we're going to divide by 2, both sides. 2 is going to cancel each other, leaving us with X. And 55.8, not 5508, 55.8 divided by 2. It's going to give us Yeah, that's right. 27.9. I'm like, wait a second, does that make sense? 27.9. So this is what she drank yesterday, right? And yes, okay, 2 days ago. 2 days ago she drank that much. She drinks 100% more. We're basically doubling that. So, yep, indeed, 27.9 times 2 is indeed 55.8. So the answer seems to be good to go. Warren receives money from his relatives every year at his birthday. This year, Warren received a total of, this is our new amount, that's 48.3% more than he received last year, so this is an increase. And how much did he receive last year? So this is the original amount. So since it is an increase, we're going to take 100% and add the increase of 48.3% for 148.3%. We want this as a decimal. Move the decimal over 2 places. We're going to get 1.483. So this is our decimal that represents the amount of increase that we're going to multiply the original amount by. So the original amount is going to represent that with the variable x. We're going to multiply times 1.483. And whenever we do that, that would produce our new amount of $1,012.60. Let's divide by the 1.483 so we can isolate that variable x. What we do to one side, we're going to do to the other. And the 1.483 is going to cancel on the left, leaving us with just x. And 1012.6 divided by 1.483 is going to give us a result of, it says to round to the nearest cent. So I'm going to go ahead and go to the hundreds place. 682.805. Now it says to round to the nearest cent, which is the hundreds place. So look to the right, 5 or more raise the score, right? So that 5 is going to bump that to 0 to a 1. So we got 682.81. So $682.81, and which is less than our new amount. And it was an increase, so indeed it does seem to make sense. And 48.3% is nearly 50%. So if we were to increase this here by about 50%, 12, yeah, it seems to make sense to me. Good to go. And final question. The average low temperature for February in Javier's hometown was 28 degrees Fahrenheit, which is 28.2% lower than the average in January. What was the average low temperature in January? So this is the original amount. This is our new amount. And it is a decrease, right? Lower. So we know with a decrease, instead of seeing what we're losing, 28.2%, let's consider how much of the temperature we're going to keep. So that would be the difference of 100 and 28.2. So let's go ahead at 28.2, and we're going to subtract that. I could go ahead and, I'm just going to use a calculator for that one. 100 minus 28.2. And that's going to give us a difference of 71.8%. Now we want this as a decimal, right? So let's move that decimal over 2 places to the left, and we'll get 0.718. This is the amount of decrease that we want to decrease the original amount by. So we want 0.718 of the original amount. Of means to multiply. So we're going to take x times, in this case, our decrease of 0.718. We're actually decreasing by 28.2%, but we're considering how much are we getting to keep, or how much of the temperature remains, and that'd be the 71.8% that we write as a decimal. So that's where we get that 0.718, and the new temperature is 28. So let's go ahead and divide both sides by 0.718. What we do to one side, we do to the other. And now 0.718 will cancel on the left, and then 28 divided by 0.718 equals 38.997. It says round to the nearest tenth, so I'd stop there. So here's the nearest tenth. So in this case, I look to the right, the 9 is going to raise the 9 to actually like a 10, which means it's going to bump this 8 over here to a 9. So I'm actually going to end up with 39, because whenever I raise this tenth from 9 to a 0, that's going to then bump that 8 to a 9. And since they do want it round to the nearest tenth, I'm going to go ahead and include the 0 there. So whenever I type my answer in, I'll put 39.0. All right. Quite a few questions there. It's about a good 30-minute video. So if you hung with me, thanks for being here. All right. So at any rate, that is all I have for IXL A1.D.6 percent of change, where we found the original amount and they indeed were word problems. Good luck with your activity.